Hello everyone, welcome to the First Thursday Club for July. We have a special treat for you today with Professor Delahay here, going to be talking about evidence and ecological consultancy. Before we do that though, I'm going to just go through some housekeeping. Those of you that have joined us before will be familiar with this, but I'll just quickly gallop through it. We obviously mute everybody's microphones while Des is going to be talking, but we do want to hear from you. We absolutely want questions. So there is a question box in your on your screen there, which you can then submit questions, and I'll be keeping an eye on those as Des is talking. At the end of Des's talk, we will have a Q&A session, and I'll try and deal with as many of those questions as we can. After the presentation today, we'll be emailing out a questionnaire. And so if you could take the time to fill that in, it really enables us to tweak what we're doing and hopefully respond to requests for future webinars. Right, so Des, I've had the privilege of knowing Des for a very, very long time. We were both researchers and academics back in the day working for an agency of DEFRA. Des had the delight of supervising my PhD. And I'm sure he would agree that it was the highlight of his professional life. Round about that time, I convinced him to join Biocensus, and we haven't looked back, really. He now splits his time working for what is now the Animal and Plant Health Agency, APHA, which was what the agency from DEFRA became, looking mainly at badgers and TB and interactions of epidemiological issues. He also has a chair at Exeter University, so we all have to call him Professor, and he insists on this. But actually, and most importantly from my point of view, is the Director of Research for RSK Biocensus, and its research and the evidence base of which our practice relies is something that is really close to my heart and to his, and I'm sure he's going to tell you all about that now. Over to you, Des.
Thanks very much, Tim. So yes, I'm going to talk a little bit about evidence in ecological consultancy over the course of the next half an hour or so. So we use evidence all the time to inform the decisions we make in our lives and in our professions. But in a technical profession like ours, evidence is really critical because it underpins our advice and the practical interventions that we implement. So I'm going to start by talking about different types of evidence and their relative strengths. Then I'm going to discuss how we're doing as a profession in terms of evidence-led practice, before I finally discuss the challenges as I see them for the future of our profession. And you'll see that I've given my talk this strap line of uneasy bedfellows or peas in a pod, and I'm sure that many of you will already have a view as to where our profession sits on that spectrum. And hopefully over the course of the next half an hour, you'll understand where I think we sit on that spectrum. So anyone in our industry will be aware that there's an enormous amount of guidance that we use to help inform our practical interventions and the advice that we provide. So the information that's contained within all of that published guidance has essentially become standard practice for us. But where does it all come from? Where is the evidence that underpins it? And that raises the question of, are we practicing evidence-based ecological consultancy? So this is a long-standing hobby horse of mine, and also actually of the other founder directors of Biocensus, because we all came from research backgrounds. So we were trained as scientists, and when we started in ecological consultancy, we were a little bit surprised at the extent to which a lot of practice was not underpinned by strong scientific evidence. This has gone missed by others. Bill Sutherland and Andrew Pullin and colleagues published this very important milestone paper back in the early 2000s, in which they advocate the need for evidence-based conservation. What I mean by that is the systematic application of what we call empirical evidence to conservation management. They noticed that in a lot of conservation practice, the evidence base to underpin the effectiveness of the measures being implemented was pretty poor. And really, they took their lead from an initiative that came earlier, perhaps in the 80s and 90s, amongst healthcare professionals in the UK, who similarly noticed that health interventions were not always supported by strong empirical evidence for their effectiveness. And so they started to develop an infrastructure to allow evidence to be incorporated in decision making in a more transparent way. So when we talk about the application of empirical evidence, what we're talking about is evidence that's derived from the use of the scientific method, which I'll describe in a moment, and also from practitioner experience. So what is scientific evidence? As mentioned, it's derived from the application of this thing called the scientific method. And the scientific method is the process of objectively establishing facts through testing and experimentation. I thank this chap, the Greek 4th century philosopher Aristotle, for the basic building blocks of the scientific method. He pioneered techniques in logic, observation, inquiry, and demonstration that underpin. And essentially, the scientific method involves more or less the steps you can see on the screen here. They involve an observation. So, for example, I may observe that having looked at many different ponds in the southwest of England, I find that I only tend to see newts in ponds where there are less or no fish. And from this, I might develop a hypothesis. So I might hypothesize, I think that fish are having a negative impact on newts. And as a result of that hypothesis, if I want to test that hypothesis, then I'll invent a prediction. So my prediction might be that if I go to a pond that's full of newts and I pour in a load of fish, a pretty unethical thing to do, but if I pour in a load of fish, I predict that the newt population will decline, perhaps to extinction. And so I might test this. I might test this by conducting an experiment where I look at a whole range of ponds where there are newts present, and in half of them I pour in a load of fish and see what happens. I'm not suggesting that anybody go ahead and do this, but it just illustrates the point. This is an experiment designed to test whether the presence of fish has an impact on the newts. I would then analyse the results and come to some conclusions. And that study would provide fairly compelling scientific evidence for what happens when fish are added to ponds where there are newts. And it would become even more compelling evidence if others were to repeat that experiment and find the same results. And so this is generally the form in which science moves forward. There are two sources of empirical scientific evidence. The first is an experiment, like what I just described with the newts, but the second is observational studies. So, for example, I might just observe different ponds around the southwest of England, and I might note whether they contain fish or newts or both. And as a result of that, I might be able to tell that there's a relationship between the presence of fish and the presence of newts. Both are perfectly acceptable ways of creating empirical scientific evidence, and your evidence needs to be summarized in a published study. And in order to get your study published, you would have to go through a process of peer review. So you submit your paper to a journal, they send it out to your peers, experts in this field that you're working in, and these experts will tear your study apart. They will try to find any flaws in it whatsoever, and hopefully they will improve your published study. In the worst cases, your study might be flawed in some way and might not be worthy of publication. And so it's a rigorous process of gathering information and getting it out there into the public domain. And that's why empirical scientific evidence is the gold standard in terms of the kind of evidence that we would want to underpin any decision making, any interventions. But there are other types of evidence as well. In our profession, we use what are called secondary publications. These aren't peer-reviewed scientific papers, they're reports and guidance and so on. And they attempt to collate knowledge in a particular area and then provide a distillation of that and recommendations for practical interventions that follow from the evidence. There's expert opinion. So expert opinion might be something that we could draw upon to help us understand what the evidence means. There's practitioner experience, so the experience of different practitioners working in the field. Then there's common sense and first principles. So in the absence of any published evidence or any expert opinion, perhaps a problem is pretty new to emerge, then we might have to rely on some common sense, logical thinking and first principles to work out what might be the best way of dealing with the problem. But these are all different forms of evidence that could help inform a decision. But you can see that this non-scientific evidence is likely to be less reliable than the empirical scientific evidence. And that's because it's subject to all kinds of unquantifiable bias. There are individual preferences perhaps involved. So some people, some experts, some practitioners may practice in only certain parts of the country, and their experience is born out of what happens when they carry out interventions in those locations. And that may not be, it may not be possible to extrapolate their experience to other geographies. Then there's personal preferences. People like, the way they do things and may stick to the way they do things because it fits in with their worldview, or in some other way it just fits in well with the way they like to work. And then, dare I say it, there is a possibility that that people have vested interests. So as commercial outfits, perhaps we might on occasion have been inclined to build an artificial set where perhaps there wasn't an awful lot of evidence to suggest it would be effective, or an alternative means of solving the problem might have been available. These things do happen. And then there's this interesting phenomenon called the anchoring effect, and this is where information that's obtained earlier is given a greater amount of weight, given more weight. And so information emerges about how to deal with a problem, and people coalesce around that piece of information, they support it, and then it becomes quite difficult to move that way of doing things out of the way when new evidence emerges. But it's often difficult to determine the origin of the received wisdom that's in circulation. We don't always know what kind of evidence is underpinning various different recommendations or different practices. And as a result, myths can develop and they can perpetuate. Now, we've talked a little bit about scientific evidence being the gold standard, but I just wanted to mention the importance of expert opinion. In the absence, particularly scientific evidence, expert opinion is a really invaluable resource. But it's quite difficult to collate all of the experiences of practitioners to distill it into a summary of guidance. Expert opinion is also very useful for assessing evidence from disparate sources. So a whole series of different scientific studies may have been carried out on a particular area of interest, and expert opinion can be used to distill out of that what it means in practical terms for our interventions. And the conservation evidence team have been good at producing synopses based on expert interpretation of evidence, and I'll talk about those a little more later. So, are we achieving evidence-based practice? On a paper by Hunter et al., which was published in 2021. And in this study, they reviewed 50 UK housing planning applications during a 10-year period. Now, they identified 446 different mitigation and compensation recommendations, and these related to 65 specific different measures and 8 different taxa. Well, what they found was that only in 56% of instances was published guidance actually cited, and less than 10% of that guidance cited any empirical evidence in support of the recommendations. In fact, in several instances, the guidance just simply cited other guidance. And this is a phenomenon that we call circular referencing. Most of the supporting literature that was used was over 20 years old. And as a result of all of this, over 50% of the measures that were recommended had insufficient empirical evidence. It was either irrelevant, evidence was absent, or the evidence that was available was not being used. So you can see that's a pretty damning indictment of where we find ourselves. So this would seem like a good moment to introduce a little beacon of hope and to talk about the conservation evidence database. You can see the address of the website at the top of the page there. Now this is an initiative to collate evidence on the effectiveness of different practices in conservation. And what they produced is a searchable database, and you can search it by intervention type, or you can search it by speed little search for interventions related to bats, the kinds of interventions that we might carry out as consultants. And I managed to extract this information here, this summary. And you can see that in the top row there, we've got an action leaving bat roosts and roost entrances unlit, which has been deemed on the basis of 5 empirical studies to be beneficial. So its effectiveness has been assessed as beneficial. However, underneath the next 4 rows, for these different interventions, we can see that the evidence collated from the various studies available suggests that they're only likely to be beneficial. So not quite such strong evidence to underpin them, but nevertheless, the evidence suggests they're likely to be beneficial. And then at the bottom, you can see 2 practices which are carried out fairly routinely in consultancy work, for which the evidence of effectiveness is either unknown or it's extremely limited. Output from the conservation evidence team are these synopses of evidence. This one you can see on the screen relates to bat conservation, but they publish them on a whole variety of different topics, and you can download these synopses directly from the website. And I strongly urge everybody to familiarize themselves with these really useful resources on this website. You won't find everything that we carry out in ecological consultancy listed here, but you will find some of the things we do listed and their relative effectiveness. So let's move to something that I actually know something about rather than bats, which is badger mitigation. For the success of badger exclusions, for example. Well, I did a Google Scholar search, so that should turn up any scientific papers, any published papers on this subject matter. And in the first 10 pages of that, the search results, I found only 4 hits, and only 2 of these were relevant, and they only studied urban badger sets. So there's a pretty limited evidence base on which to assess effectiveness of exclusions. So I looked at evidence for the uptake of artificial sets. Again, I did a Google Scholar search, and in the first 10 pages, I got 6 hits. But only 3 papers were actually looked at the effectiveness of artificial sets in terms of their uptake by badgers, and the evidence of their effectiveness was extremely patchy. There was very low uptake of sets. It tended to be very temporary. In fact, usually less than 6 months. So badgers who occupied artificial sets after exclusions tended not to stay there for longer than a few days, quite often, and for a maximum of 6 months in the published evidence. And evidence of breeding at artificial sets was really quite rare. I also looked at the conservation evidence database, but unfortunately this is one of those areas that's not represented at all yet on the database. Now, what all that tells me is that there's very limited evidence to support the effectiveness of exclusion of badgers to artificial sets, and yet we carry out that work very widely. It's a widely used approach to dealing with problems of badgers on development sites. And in fact, Natural England issued 1,471 exclusion licenses between 2019 and 2020. And many of those licenses will have been for multiple sets. Some of those licenses will in fact have been for quite a large number of sets because they will have related to large infrastructure projects. So you can see that we're doing a lot of practice in terms of badger mitigation that's not terribly well informed by the evidence base. So if the evidence base for effectiveness of many interventions is poor, then how do we change that? How do we test interventions to see whether they actually work? Well, the first thing that we need to do is to define what effectiveness is. So it's really important to understand what success looks like in terms of the interventions that we carry out. So, for example, the occupancy of bat boxes has been used in the past to indicate the effectiveness of this approach. And yet it's also been widely criticised for being a very poor indicator of effectiveness because it tells you nothing about the conservation benefits at a population level. The real test of effectiveness of an intervention look like? Well, it looks like a properly designed ecological experiment, which would mean that it's got controls, so places where you don't do the intervention and you observe what happens to the subject species in that situation. It means that it's replicated, so you have lots of controls and lots of treatment sites, and it means that it's randomized, so that your treatment sites and your control sites are random. You don't pick the treatment sites in anything other than a random way. And if you set your experiment up in this way, then this gives you good evidence of cause and effect. An alternative, as I mentioned before, when we looked at the newts and fish example, is to carry out an observational study. And all an observational study tells you is about correlations. It doesn't tell you cause and effect. It probably suggests evidence that's consistent with cause and effect, but it's essentially just telling you about correlations. Nevertheless, it's a very useful approach for getting some insight into what may be effective and what's not. But these kind of scientific endeavours are very challenging for practitioners to carry out. We're busy enough with the day-to-day job, and so this is where the value of meta-analyses carried out by academics or expert summaries of studies come in, and that's really where we need to be looking for most of the evidence that we need to support the work that we do. So I'm going to talk a little bit now about something called evidence complacency, and this was described by Bill Sutherland and Claire Wordley in a paper published in 2017 in Ecology and Evolution. And what it describes is the situation where there's a very heavy reliance on existing guidance and practice, even in the absence of evidence that it works. And I think this adequately describes the situation that we find ourselves in. There are reasons why one might find ourselves in this situation. One is that there could be difficulties in accessing and assessing evidence if it's out there in very disparate form, although this is getting a lot easier with things like the conservation evidence database and various synopses of evidence becoming available. There are also complex, more psychological reasons really related to practitioner attitudes towards evidence that create a kind of inertia that mean that practitioners like to hold on to the way they do things rather than moving forwards and changing the way they do things in the face of new and emerging evidence. As I say, this environment creates a very strong inertia against any change. Example of that inertia is the situation of bat gantries. So bat gantries were originally conceived as an idea for allowing bats to pass over busy roads above the traffic, and they were used for probably about 9 years in the UK until they were shown to be ineffective, basically. And yet they still continued to be used after that point. So what this is suggesting that kind of inertia in the culture, in the system, means that providing the evidence is not enough in itself. There needs to be some kind of engagement directly with practitioners in order to push changes in the way we carry out the work we do. So I think by now you've probably gathered that we're more at the uneasy bedfellows end of the spectrum as a profession in terms of our relationship with evidence than at the peas in a pod end of the spectrum. So why does ecological consultancy have such a strained relationship with empirical evidence? Well, you'll be relieved to know that it's not all our fault. There are some reasons why this is the case, and one of the most important is that really our job is to provide best available advice. It's imperative that we do that in order to try to mitigate the impacts of development. So even in the absence of evidence, we need to provide the best available advice we can. The regulatory framework that we work within relies extremely heavily on the guidance. The guidance has become standard practice, and that's reflected in the requirements of the regulatory framework. And this encourages a kind of box-ticking approach to carrying out interventions. And everyone is invested in this evidence-poor environment. Our clients, ourselves as consultants, and the regulators, we're all invested in this evidence-poor system. There are costs related to the collation of evidence, doing the research necessary to fill knowledge gaps, and updating guidance. And so that creates a potential barrier to changing things in the light of new evidence. And I think as a profession, we can be guilty of being protective of some of the received wisdom and not moving forward as new evidence emerges, or not wanting even to engage with the prospect of there being new evidence. There's a general reluctance, I think, amongst many consultants to try to wrestle with the evidence base, the disparate evidence base that may be out there, to try to work out whether an intervention is likely to be effective. And instead of doing that, we tend to rely on just carrying out what the guidance recommends. And so this creates an understandable psychological inertia in our profession, and we tend to stick to, as I say, what the guidance says. But we can't go on like this. If we scale up the impact of evidence-poor interventions, it can have a significant effect. We could be implementing methods that are ineffective. At worst, we could be implementing methods that are actually harmful. In the literature that I've been looking at over the past few weeks to do with the evidence that underpins our practice, destructive searches for reptiles and amphibians came up fairly often. As a widely used technique, it has very little or no supporting evidence that it's effective. And some have even suggested that it might be detrimental. Similarly, if you look at studies of reptile translocations, most of them suggest poor survival of the individuals that are translocated and high levels of dispersal away from receptor sites. And that rather defeats the conservation goal that's intended. Going back to badgers, then we've seen that there's scant evidence of the effectiveness of exclusion and artificial sets. And if we take just the example of one well-known large linear infrastructure project, which RSK Biocensus had the pleasure of working on recently, we looked at I think it was about a 16-kilometer stretch of this route where we carried out badger exclusions and built artificial sets. And if we scale up our experience over that 16-kilometer stretch to, let's say, 75% of the first phase of that large linear infrastructure project, that would amount to something in the region of about 1,052 badger sets being closed, 104 of which would be main sets, and at least as many artificial sets would therefore need to be constructed. So you can see that when you scale up these kind of interventions, we're having quite an impact on ecosystems. So what are the consequences of implementing evidence-poor interventions? Well, the first is that your conservation goals may not be realised. And there is a danger in some circumstances that we may even be contributing to a decline in biodiversity in some circumstances. Carrying out evidence-poor interventions is also, it's a waste of money and it's a waste of resources, and it reduces the credibility of the profession because interventions appear to be unjustifiable. So how can we do better? Science is based on the published guidance. And in this paper produced by Harriet Downey and colleagues, they reviewed 301 guidance documents used in conservation. And that included guidance documents used to inform practice in our profession. And you'll see that in the list of authors are a couple of very experienced ecologists. Out of those 301 guidance documents, only 29% had any references whatsoever. 9% of them had references, had relevant references. So an awful lot had references that were not relevant, that did not directly support the effectiveness of a recommendation. And 63% of those published guidance documents that had a date on them were over 10 years old. So it's clear that evidence is not being cited and that the evidence being used in guidance may be out of date. So how do we do better? How do we make things better? Well, the authors of this paper listed some principles for developing more robust guidance in the future, and I'm not going to go through all of them, but the standout ones are to incorporate scientific evidence, as we've discussed, to review all of the evidence and update it regularly, and that the guidance should therefore also be updated regularly as new evidence emerges. They argued for objective interpretation of the evidence, and this is where expert opinion can come in very useful. And they argued for something called evidence transparency, and this is where for any given recommendation you are absolutely transparent about the type of evidence that you've used to support it and the strength of that evidence. When there isn't any published scientific empirical evidence, then you have to use other forms of evidence, but we need to be absolutely transparent about what those forms of evidence are and what their limitations are. And if you want to know more about how you might formalize that approach to assessing the evidence base on which to base a decision, then you could look at the evidence to decision online tool, which is provides a very useful framework for doing just that. So what are the challenges for our industry as I see them? Well, I think there are some short-term and things that we can do as individuals. First and foremost, I think we need to, as individuals, understand the different sources of evidence and their different relative strengths. We need to learn how to access evidence, whether that be in the form of the online databases like the Conservation Evidence Database, and there are others out there as well, or whether that's getting access to scientific publications, and that's becoming increasingly easy because more and more publications are now what we call open access, so you don't need to pay for them. We also need to learn to treat the guidance as just that, as guidance. It is okay to deviate from guidance where other evidence suggests that a different approach may be more effective. And we need to be transparent about our decision making. As I said before, we need to be very clear about what evidence we're basing any decisions on. And I think we collectively need to lobby and get involved in helping to update the guidance that's out there at the moment. Longer term and more collectively, I think we need as a profession to invest in the evidence base. So we need to be funding the collation and review of existing evidence. We need to be promoting post-intervention monitoring as a source of information to help inform what is and is not effective. And we need to be investing in research projects, probably in collaboration with academics. And we need to, as a profession, commit to the idea of evidence-based practice in everything that we do. And I think that the tide is definitely turning. There are reasons to be hopeful. More evidence summaries are becoming available. More publications are open access, becoming more available to the profession. There's a growing awareness, I think, of this problem of evidence gaps in our industry. England have just recently announced a transition from evidence-based to evidence-led position. I'm not entirely sure what the subtle difference between those two phrases is, but nevertheless, they have an encouraging statement, which is that they want to ensure that the best available evidence is central to their decision-making, their delivery, their advice, and risk assessment. So that's all very encouraging. And then we have initiatives like the Conservation Evidence Champions Initiative, brought forward by the Conservation Evidence team. And this allows organisations to subscribe to become conservation evidence champions and to get support from the Conservation Evidence team in making sure that what they do is backed up by evidence. So it's all very well me going on about what we need to do as a profession, etc. But our RSK Biocensus actually practicing what I'm preaching, moving in the right direction. We were very formative, Tim especially actually, in the initiating the bird survey guidelines website, which is a forum where you can find all of the current available bird survey guidance, where people can discuss the guidance, can submit new evidence to suggest changes to the guidance, and can identify knowledge gaps where research might help to better inform how we carry out bird surveys. We've also been very heavily involved in the cyan bat mitigation guidance, which should be available shortly. And we've been actively supporting research, as many other consultancies do. We've had a handful of MSc projects, but we've been committing to fund PhD studentships. We're currently looking at an application to fund a PhD studentship on the impact of noise on bats. And we've funded, I think the advert is out there now for a student, for a PhD on managing gulls on offshore infrastructure. Within the company, we're developing a science strategy. As Tim mentioned at the beginning, I'm responsible for the development of that. And I think gradually, as an organisation, we are starting to turn the tide on the way we evidence our decision making, and we're committed to promoting evidence-based practice in everything we do. But as with all other consultancies, we work within the restrictions of a system that relies very heavily on the guidance in order to carry out mitigation and so on. But I think that we're gradually moving in the right direction, well, I hope you agree. So thank you very much for your attention, and I'll hand it back over to Tim.
Thanks very much, Des. Sounds like I've got an awful echo, but hopefully we'll. Oh, it's gone. Excellent. Okay, so we've got a bunch of questions in, so if we'll go straight onto that, if that's okay. First one is from John. It says, gathering evidence in a robust scientific way is highly involved and time-consuming. Consultancy often deals with relatively short-term projects with a limited budget. How can we square this circle to learn lessons about the effectiveness of our mitigation in a rigorous way, and will the clients pay?
Yeah, well, that's a very good question. So, I think we shouldn't lose sight of the fact that the empirical scientific evidence is our gold standard. So that's the aspiration, that everything we did would be underpinned by robust empirical evidence from scientific studies. But as John points out, that's very involved carrying out those studies and so on. So although we can start to partner with academics and so on to fill some of the important knowledge gaps, that will take time. So in the meantime, we have to rely on other sources of evidence, but we just have to be very transparent about where that evidence comes from. I think one important tool that we as consultants can try to get more traction with is post-development or post-intervention monitoring. So post-intervention monitoring across a whole broad swathe of different interventions that we carry out could provide huge amounts of data that could be useful for trying to get a feel for what works and what doesn't. Again, as I pointed out in the talk, that will be correlational data because it's observational, sort of experimental, but it's still extremely useful in informing, giving us some confidence really in what works and what doesn't. So I think this is a slow, long journey you know. And I think it starts by us being transparent about the kind of evidence that we are using to underpin the practice that we carry out. We can't expect to have robust scientific evidence for everything we do. Not right now. That's the aspiration.
Yep. Thank you very much. Be unsurprised to know that I agree with you on that. We have a question here from Samantha. One of the fundamental issues we face is, as you mentioned, the lack of empirical evidence. For example, your badger set example. How do you think we as a profession can best move forward in building of the relevant evidence bases across the range of species on which we work? Could the bird survey guidance approach be expanded to other taxa?
Yeah, I think it definitely could. I think we need to create circumstances where practitioners can feed in their experience and are able to have sort of collective discussion about the merits or otherwise of survey guidance or mitigation guidance, compensation guidance, etc. And I think we also need to encourage us as a profession to identify where the important knowledge gaps are, and then to link up with academics to try to help fill some of those knowledge gaps. And I know that that's one of the intentions of the Bird Survey Guidance Initiative, and you could certainly expand that to other taxa. I think it's a great model for starting to get people together to look at the evidence in a critical way and to start to share their experience as well. As I mentioned early on, you know, expert opinion and the experience of practitioners, they're really important sources of information, especially where we don't have scientific evidence. But collating their experiences is a real task, you know. It's very difficult, and those kind of websites, creating a forum where you can do just that, I think they're really useful. Also, the advantage of having an interactive web-based approach to guidance means that it can be updated so much quicker in the face of new evidence, and it can get out there to the audience it needs to get to much quicker.
Thanks, Des. Got a question here. It's quite long. Thanks, Carlos. But so bear with me. One of the issues with evidence-based approach is the lack of scientific interest in some basic recommendations that ecologists make. This is made clear in the Hunter et al. Paper, where some of the unproven mitigation measures, including not removing habitat during the bird nesting season or fencing off and retaining habitat that will be present post-development. Sorry, it's just moved. Do such basic recommendations actually need evidencing by scientific publication? I guess the gist of that is some things are so blindingly obvious. Does it really need to have the empirical evidence behind it?
Well, perhaps in some circumstances, you know, the expert opinion, first principles, logical thinking, and common sense, you know, is sufficient to provide enough confidence that a certain intervention is going to have a beneficial effect. Some things are, you know, blatantly obvious, aren't they? And you don't necessarily need to carry out an experiment. We need to be sensible about where the evidence gaps could be filled by rigorous research, and where they can be more easily informed by you know, expert opinion, practitioner experience, and so on. I also take the point from the earlier part of that question that sometimes academics aren't terribly interested, maybe, in doing some of the research that would help us an awful lot in informing the practice that we're involved in. But I think the job there is for us to impress upon academics, to go out there and engage with academics, impress upon them that the work that we do has really significant societal impact, and that means that research that underpins that also has societal impact, and it's really important to researchers these days that their research has societal impact. So if we can point out the importance of getting to the bottom of some of these questions to academics who may not understand how important they are in a practical sense, then we might get a bit more traction.
There's a bunch of questions here that essentially are oscillating around the same question, which is who's going to pay for this? And I think it comes down to the difference between what you would do as a scientist and the cost implication, and what you need to do as a consultant in order to get our clients' consent for their projects. You know, if we look at post-construction monitoring, obviously most people, you know, they've got the consent, they're not going to then start shelling out money for the post-construction monitoring, and why should they? So how do we change things so that there's enough funding in the system to actually start doing some of this research?
Well, I think the first thing is that we need to change our culture. We need to change the way we view evidence. So we need to understand that there's a lack of evidence supporting a lot of the things that we do, or that there's only weak evidence, and understand that we need to change that. And then we need to really advocate ways of working that will help us to fill some of those evidence gaps. So in the case of post-intervention monitoring, you know, we need to be lobbying the regulatory authorities really to have some muscle in that area, to start to really see that it's in everybody's interest to gather post-intervention data so that we can be better informed about the effectiveness of things. Where we can, we should attempt to cobble post-intervention monitoring on our projects, but I understand there are commercial reasons why that might not, you know, be acceptable a lot of the time. We have to gradually push things in that direction. I think the regulatory bodies are going to be really pivotal in getting any post-intervention monitoring regularly undertaken.
Okay, I think we'll probably finish on one last question. This is from Steve. How should scientific evidence be transmitted to ecological consultants? Do we expect consultants to read scientific papers, or do scientists need to write articles specifically for consultants? A very good question, like that.
Yeah, that is a good question. I think the conservation evidence database and their synopses of evidence is an attempt to bridge that gap between practitioners and academics and academic studies. So I think that's a really good model for doing that. But I do think that also, as a profession, we need to become more comfortable with the ideas of the scientific method, with how scientific evidence, why scientific evidence is so robust and important, and in understanding these different sort of levels of strength of different sources of evidence. So I think that perhaps we do need to get better at going out and reading papers in the scientific press. They're not as intimidating as they might first seem. We need to get better at doing that, but we also need to use the resources that are there for us, for practitioners, like the conservation evidence database. I mean, I would strongly urge everybody to take a look at that. You know, it really is that bridge between the academic studies and the practitioners that we need. And as I say, I think that model is the way to get information disseminated throughout the world of consultancy.
Okay, we have a bunch of other questions, but I think we've run out of time. So rest assured, rather, that we'll get Des to respond to you via email for the questions that we've not got around to. Thanks everybody for joining today. It's been fascinating. Thanks, Des, for the presentation. We're going to have a summer break for the First Thursday Club in August, and we'll be back on the 1st of September. So check your emails for notifications for what we're going to be doing through the autumn. But thanks once again to everybody, and thanks once again to Des. We'll see you then.
Thank you. Bye-bye.